Today we're going to work on solving one variable inequalities. So in this lesson we're going to be solving and graphing inequalities that are in one variable. As we begin, we need to talk about what inequalities are. So when we take a look at inequalities in the past, we remember that we have inequalities that are less than, or they might be less than or equal to. We also had inequalities that were greater than, or we had inequalities that were greater than or equal to. And what are inequalities used for? Well, they're really used for comparing two values. For instance, if I said that my height is less than my friend's height, I'm comparing two values, my height and my friend's, and so we are using inequalities to compare. Here are the words that might be associated with our inequalities. We have less than, and it can also be described as fewer than. We have less than or equal to. Also, this phrase, at most, can be used to describe less than or equal to. For instance, if I said she has at most $20 in her checking account, that means she has $20 or less, which means it's less than or equal to. We can also use the phrase no more than. When we see this symbol, we might say it is more than, greater than, or higher than. And this symbol, greater than or equal to, and also the phrase at least, which is a little tricky. So if I say you have at least 2 pieces of candy, that means you could have 2 pieces or more. At least. Okay. We see and use inequalities all the time around us in our world. For example, speed limit signs. It tells me that the speed limit is 50 miles an hour. It's a limit. That means I can't go any higher than 50 miles an hour, although we know some people do. So we could write an inequality that describes the speed limit. So if I said my speed, I'll use the letter S to represent that, cannot be any more than 50, that means my speed has to be less than or equal to 50. You might also see inequalities when you're going to an amusement park. In this case, this sign tells me that I have to be at least 52 inches tall to ride that ride. So my height has to be greater than or equal to 52 inches if I'm going to ride that ride. So let's take a look at some phrases and let's see if we can write these in symbols. The food will cost less than $7. So my food, F, is going to cost less than $7. In the next example, it says you need to get at least 82% on the test. So my score has to be at least, meaning it has to be 82 or more. So greater than or equal to 82. In the next example, it says you can have at most 2 cookies. That means you can't have any more. So I can only have 2 cookies or less. So I'm going to be less than or equal to 2 cookies. That is how we write statements into symbols for inequalities. Now let's take a look at the next one. Katie has $20 to spend and wants to buy bracelets that cost $1.30. But first, she had to give her little brother $3. It says write an inequality of how many bracelets she can buy. So Katie starts with $20 But first, she had to give her brother $3. So I'm going to take away the $3, and that leaves me with $17. Now, she wants to buy bracelets that are $1.30. So I can take 17 and divide that by $1.30 to find out how many bracelets that Katie can buy. When we do that, it comes out to be about 13.1. So what we would like to say is she can't buy more than 13 bracelets, because if she does, she's not going to have enough money. So Katie can buy, her bracelets have to be less than or equal to 13. Alright, let's do a little bit of review with graphing of inequalities. A couple of reminders. When you graph an inequality, the first thing we're going to do is we're going to graph these today on a number line. And when we do graph them on a number line, we want to make sure we remember that if it is less than or greater than, we're going to use an open circle when we graph. If we're going to use less than or equal to or greater than or equal to, we're going to do our closed or our filled in circle when we're graphing our inequalities on the number line. The other thing to remember is we always must look at the variable first. What I mean is, if you had an example like this, y is less than 5, that means that any number that's smaller than 5 would make my inequality true. However, if I have my inequality written as 5 is greater than y, that means the same thing. Please look at the variable first. Y is less than 5. They could be written either way, and they mean the same thing. So let's take a look at a couple of more examples before we start solving inequalities. Let's take a look at this chart. What I want to do is I want to fill in the chart, and then we're going to see if we would be anything happens to the sign, the inequality symbol, when we do some math operations. Let's take a look at the first one. 2 compared to 4. Well, we know that 2 is less than 4. What would happen if I added 2 to both sides of my inequality? So I have a 4 and I have a 6. Let's compare 4 to 6. Well, 4 is less than 6. Did my inequality symbol change when I added the same quantity to both sides? No. Next, let's go back to the original inequality. 2 is less than 4, and I want to subtract 2 from both sides. So 2 minus 2 is 0. 4 minus 2 is 2. 0 is less than 2. So when I subtract the same quantity from both sides, my inequality symbol does not change. If I go back to my original and I multiply by 2, I have a 4 and I have an 8. 4 is less than 8. So if I multiply both sides by a positive 2, a positive value, my inequality symbol does not change. But what happens if I multiply by a negative 2? So back again to my original inequality, 2 times negative 2 is negative 4. And 4 times negative 2 is negative 8. Now we know that negative 4 is greater than negative 8. So if I multiply both sides of my inequality by a negative number, my inequality flips or reverses. Let's take a look at division. So back to your original inequality, 2 divided by 2 is 1, 4 divided by 2 is 2. 1 is less than 2. So my inequality doesn't change from my original. It still stayed less than. But what if I divide by a negative 2? Well, 2 divided by negative 2 is negative 1, and 4 divided by negative 2 is negative 2. Now, negative 1 is greater than negative 2. So if I divide by a negative 2, my inequality symbol is going to change. It's going to reverse or flip. That's going to be the difference between solving equations and inequalities. We have to remember that if we are going to divide or multiply by a negative number, we have to flip our inequality symbol. Let's take a look at our first example with solving. I have 3x plus 4 is less than 7. Other than the fact of flipping the symbol when we divide or multiply by a negative number, we're going to solve these the same way we did equations. We're going to do the opposite operation, so I'm going to subtract 4 from both sides. I have 3x now is less than 3. And now I'm going to do the opposite operation, which is to divide both sides by 3. And my inequality remains the same. So I have x is less than 1. Now to graph. Simply draw a number line and place a tick mark on the number line at the value of your solution. Because it is less than, we want to make sure that we have an open circle. And now we need to shade all the values that will make our inequality true. Any number that is smaller than 1 will make my inequality true, such as 0, negative 1, etc. So I will shade to the left, and that is where the numbers are smaller on the number line. Let's take a look at our next example. So we have 7 minus x is less than or equal to 5 over 2. So the first thing that I might want to do is I might want to change 5 over 2 to a decimal if that will make things easier for you. So that's going to be less than or equal to 2.5. And I'm going to get the x by itself, so I'm going to do the opposite, which is to subtract 7. So I have negative x is less than or equal to negative 4.5 when I subtract 7. But I don't want to know what negative x is. I want to know what x is. So I am going to either multiply or divide by negative 1. So I have x. Oh, because I divided by a negative, I need to now flip my inequality, reverse my inequality symbol. So x is greater than or equal to 4.5. Now I am going to draw my number line, make a tick mark where my solution is going to be labeled at 4.5. I'm going to look at my symbol. It's greater than or equal to, so I'm going to do a closed filled in circle. And I'm going to shade to the right because that is where my values are greater than 4.5. On the next example, I need to make sure I do the distributive property as my first step in my solution. 12 times 5 is 60 minus 24x, which is greater than 6. Opposite operation, I'm going to subtract 60 from both sides. My remaining values will be negative 24x is greater than negative 54. And I'm going to divide both sides by negative 24. Now, I divided by a negative, so I need to reverse my inequality symbol. And then I either need to reduce my fraction, leaving it as improper. I can change it to a mixed number, or I can use a decimal. I'm going to use a decimal. Negative 54 divided by negative 24 is 2.25. Now I'm going to graph my solution. So I'm going to draw my number line, making sure I have arrows on both ends, and I have labeled my solution with a tick mark at 2.25. My inequality symbol is less than, so that's going to be an open circle, and less than, x is less than, meaning my values are smaller than 2.25, which means I'm going to shade to the left. In our next example, we'll want to distribute before we move anything or combine like terms. So when we distribute, we have 5x minus 6x minus 42 is less than or equal to 3x plus 9. We see that we have two x's on the same side of the inequality, so we need to combine like terms. 5x minus 6x gives me negative 1x, minus 42 is less than or equal to 3x plus 9. Now I need to move one of the x's. Again, like we've talked about in previous videos, it doesn't matter which way to go, but I think I'm just going to add x to both sides, and when I do that, my variable will be positive. So I have negative 42 is less than or equal to 4x plus 9. Now I'm going to subtract 9 from both sides, and I have negative 51 is less than or equal to 4x, and I'm going to divide both sides by 4. Now I can leave that as an improper fraction, or I can change it to a mixed number, or I can change it to a decimal. So I'm going to change it to a decimal. That leaves me with negative 12.75. And since I divided by a positive 4, my inequality symbol remained the same at less than or equal to x. So let's graph that. And if you remember in one of the first slides we talked about, we always want to start with the variable. So x is greater than or equal to negative 12.75. First thing we'll draw is our closed circle, and since x has to be bigger, we're going to shade to the right, which means those are the values that become larger. This is one that can be a little tricky because our symbol is facing the other direction, but remember we start with the variable. We start with the variable. Here's another problem that has fractions, and it's your choice. You can simply subtract 3 over 2x from both sides and then do your division of fractions, or if you prefer not to use fractions, we can, if you remember, multiply our entire inequality by the common denominator, which happens to be 30. So 3 over 2 times 30 over 1 gives me 90 over 2. Simplified is 45x. Minus 1 over 5 times 30 over 1 gives me 30 over 5, which is 6. Keeping our symbol. 8 over 3 times 30 over 1 is 240 over 3, which is 80. 80x. Since I have variables on both sides, I'm going to move one of them, and I'm going to choose to move the 45x to the other side by doing the opposite operation, which I'm going to use subtraction. So that leaves me with negative 6, keeping my symbol. 80 minus 45 leaves me with 35x. And I'm going to divide both sides by 35. So I'm going to leave this one as an improper, or as a fraction that's already reduced. So I have negative 6/35. keeping the symbol because I divided by a positive number, is less than x. Let's graph that solution. So we draw our number line, putting our tick mark and our solution labels that as negative 6 over 35. If we take a look at our symbol, it's a less than sign, so we're going to have an open circle. But remember, we're going to start with the variable. So x is greater than negative 6/35. We will shade to the right because that's where the numbers are larger. Remember to start with the variable. So to wrap up, the same operations as equations. Always look at the variable when you're doing the graphing. Start with your variable and be sure to flip the sign when you multiply or divide by a negative number. Then if you'll please complete the reflection.